Hey fellas, this is Jagbeer Singh and today we are going to design a circular water tank as there are so many requests from my subscriber for circular water tank. So the specification for the tank are the radius is 6.2 meter and the tank height is 5 meter and it is resting on the ground. And I want to apologize for being away from YouTube for a while, but it won't happen again because I was busy with some job. So, and there is a small message, don't forget to subscribe, and whenever you are subscribing then there is a small bell icon, please hit that one so that you do not miss any notification whenever I am posting a new video. So let's go to the Staad Pro and start with space. Now as this one particularly is circular, so I have to create a circular grid, so that I'm giving as C, and I'm using XG plane and the radius is 6.2 and number of bays are 6. Here we have to put 20. I will be giving this file into the description because so many of you ask to provide the Staad file also, so don't worry. So I have to add some nodes from the center. Use your control button just to add the nodes quickly. You can do like this. Now escape. Now add plates. So quickly add the plates like this. There is already a video for rectangular water tank design on my channel. You can simply watch it if you want to. Now you notice at the last plate is not rectangular, so I'm going to geometry, add plate and triangular to finish that one up. Now you see this is a small piece of pizza, so you have to rotate to complete the pizza in simple language. Before you do that, select these two nodes and transitional repeat them into y direction 5 times with a spacing of 1 meter each. Now again go for add plate. Do not rotate, I suggest you, otherwise it will be quite messy. Keep on adding plate like this. Now this way we are designing the side wall of the water tank. Now select your plates and go for circular repeat 20 times 360 angle. Now you see here is your water tank, looks like. Now all I have to do is just to define some thickness for these plates. Purposefully I am giving 2 because whenever we will be finishing the analysis there will be few messages and we will get to know how to fix those messages. So that's why I am purposefully doing this. So I am selecting this thickness and assigning it to the selected plates. Now we have to give some support as it is resting on the ground, so let's create support, fix support, and assigning this fixed support to all these bottom nodes is quite messy, so there is a trick here. So orient your model like this and select your plates of the bottom this way and right click here and go for new view and create a new window for the view. Yes, now in this particular view only those things you selected will be visible to you. So now go to the isometric view and use your cursor to assign the nodes. Assign it like this way. Assign to selected nodes. Now you close this and you see in your main view it's been reflected. So now we will be doing the toughest part, the load definition. Load definition, I divided into two portions. Sorry, load case details. First one is dead load. I'm giving title as DL and defining its specification is self weight in minus y direction with factor 1. Assign it to view. And the second load case I want to add is live load. So the first step will be finished by assigning the live load. The second and the most important one, and the technically, let's see. First I'm going for plate load, pressure on full plate. So this particular one is, as this is a water tank, so all the load of the water will be acting on the bottom, on the base of the water tank. So for that I'm giving minus 50 because it is acting downwards, and zy. So now assign it to view also. No, not assign it to view. Simply orient your model like this, as it will be acting only onto the base plates. So assign to the selected plates. Now you see it is acting downwards. But as I described in my water tank design of rectangular water tank, whenever there is a fluid or a hydrostatic anything, water or any liquid kind of thing, it tends to exert pressure on the side walls also, and the amount of the magnitude of the this pressure or load tends to increase at the bottom as maximum, and at the top it is minimum because of the hydrostatic nature. So for that we have to create one more thing, and this is the most important and technical thing. So for that I'm going to live load and going for new, go for load item, plate load, and there is hydrostatic force. So now you have to select plates, orient your model like this way, and you have to tell on which plate what is the magnitude. So I am selecting the top plates and done. And there is one more point: the magnitude of the hydrostatic force at this particular top point will be less as compared to the magnitude at the bottom. So you have to give hydrostatic force accordingly. So that's why there are two options here. So I'm purposefully giving some wrong information so that I can tell you how to fix that and why I gave this one. So I'm giving minimum as 0, maximum as 10 kilonewton in positive direction. So I'm finishing it up at, now you see when I'm orienting it like this way, now you see this particular, let's say go on the top. Now whenever you are zooming in, then the direction of the force is wrong. You see, it is coming from outwards. So that's why you have to do one more thing here. You go to the bottom and go for edit. Just for the top nodes which are on the top, give 0, and for the bottom nodes give minus direction so that it is going outwards. Minus 10 and change. Now you see the load is acting outwards, and it is minimum on the top and maximum on the bottom. So either you can do it for all these load cases, or there is a small trick how to do it. So I'm going to use my Staad Editor to do that trick. So if you don't know how to use this Staad Editor, there is already a video on my channel for Staad Editor. So now what we have to do, you have to go to bottom. Now you see this is 216, the last one on which I did the the modification. So what you have to do, you have to simply click after the plate 216 space. In your case it can be 2117 or whatsoever, depending upon how you give the nodes. So all you have to do is at the last plate you write down all these plate numbers, like space 7 space 18 space 29 space 40 space 51 62 73 84 95 106 117 128 139 150 161 172 183 194. One moment, there is a message here. 194, sorry, 183 194 205. That's it. And select all these upper and backspace and save it and close. Now you see, when you extend this load case, in that there is only one, and now you see everywhere it has been updated. Now you see the load is 0 at this point and 10 is this point. So now what you have to do, again you have to go for live load. You have to do it 5 times because we have 5 vertical plates. So I'm going to do it very quickly. And new load items, plate load, hydrostatic, select again the plates. Now the value is minimum 10 and maximum 20 CY. Last plate, change -10 -10. Now I'm doing -20 -20. Change close. Now you see it has been changed. So go for Staad Editor, this time again save, go at the bottom. Now here 819 8 space 19 space 30 space 41 space 52 space 63 space 74 85 96 107 118 129 6, and the same thing. Don't be careful, do not delete this one, and save it, close. Now again you go. Now you can see it is increasing while we are going downwards. The same way do it for the next row. It's 20 30 Let's say change this one minus 20, minus 20, minus 30. Oh, sorry, it's already having this 20, 20 minus 30. So we are going to Staad Editor, nine, 20, 31, 9, 20, 31. So here is 30, 40, add it, minus 30, minus 30, minus 40, minus 40. And save it. It's quite boring, but you have to do it, in order to get the right result. There are a simple method also, or more complex methods also, but I chose this one just to simplify. Even there are some beginners on my YouTube channel, so for them, go for new, load items, plate loads, hydrostatic. Now the last one, so it's now 40, 50, and that's it, it's finished. Just save it. And now you can see the magnitude is increasing as we are going downwards. So that was the main point. So now what we have to do, we have to analysis and print. We have to go to the design part. Now go to design, choose your concrete. Now here you can choose any design code. The modeling will be the same, only the design code will be the different. So for this particular video we are using IS456. Later on I will be showing for BS codes also, IS456. Select parameters, and I am choosing FC and FY main. Okay, and defining the parameter FC is 25000 kilonewton per meter square. FY main is 415000 kilonewton per meter square. Now assign both of them to view. Now what are the commands I want to use? I want to design this slab, yes, add, and I want to do the takeoff. Design the element, select, assign it to view, yes, and go for analyze. I told you there will be few errors purposefully, because when I was giving the thickness there was some trick. Error is saying something here. The design moment exceed limiting moment of resistance for element number 5 and everything, so just close it. Again go to general. That's why I purposefully give the thickness as 2. So edit it and make it 0.3 because it is not taking that particular load, so it's going to fail. So change it. Yes, I want to change and close. Now again go for analyze. So now there is no error. Go to output file. So now in the output file you can see our specifications. At node, what was the maximum displacement at which load, each and everything, moment and all. In concrete design, what is my element, what is top, bottom, data, you can read it out and all. So this was the video from my end, and please, if you liked it, please hit the like button. I want everybody whosoever is watching to like this video. And please comment whatever the feedback, right, wrong, whatsoever, please give it into the comment section. It makes me feel motivated. And please do not go before you subscribe this channel and hit the bell icon to get the notification whenever I am putting a new video. So this is Jagbir Singh signing off, and you will get this Staad file into description. There will be a link, so you can download this particular Staad file and you can do your R&D. So this is Jagbir Singh signing off for today. Jai India, Jai Bharat.